So we've all seen these incredible AI models that can write code, create art, you name it. But they all show this one kind of fundamental flaw. Their knowledge is totally frozen in time. What if that wasn't the case? I mean, what if an AI could actually evolve and adapt its own brain after it's been deployed? Well, today we're going to explore exactly that, the next evolution in AI.
Just think about it for a second. When you or I learn something new, we don't just, memorize raw text from a book. We process it. We take notes. We connect it to things we already know. Our actual brains change. But today's most powerful AI models, they can't do that. They're brilliant for sure, but they're static snapshots.
And this slide right here, this lays out the whole game. On the left, you've got the current paradigm, static knowledge, a one-time training event, and neural weights that are set in stone. But the goal, where we're headed, is on the right, a dynamic model that actually learns how to learn, which allows its own internal weights to adapt over time. And let me be clear, this isn't just some incremental upgrade. This is a whole new category of AI.
All right, so let's really dig into this core problem. Because the static nature of today's large language models, or LLMs, it's a massive bottleneck. And not just for the next big technical breakthrough, but for creating real evolving business solutions that can keep up with the world.
Okay, imagine hiring an absolute genius, a brilliant employee. On the first day, you hand them a giant stack of manuals and say, read these. And then you tell them that's it. That's all they'll ever get to learn. No new experiences, no on-the-job training, nothing. That is basically what we do with our most advanced AIs. They learn from data as is, which leads to a really critical question.
The simple answer? No, not even close. Raw data is almost never optimized for deep learning. The models we have today, they just don't have the ability to develop their own learning strategies. They can't figure out the best way to absorb new information. They can't rewrite the textbook into their own more useful notes.
Which brings us to a major breakthrough. A new framework that doesn't just teach an AI what to learn, but how to study and internalize information all by itself. This is where it gets really interesting.
The researchers used this fantastic analogy. Think about how a really great student prepares for a big exam. They don't just passively reread the textbook over and over, right? No, they actively engage with it. They create summaries, they draw diagrams, they list out the key implications. They're restructuring the information in a way that makes sense to them. And that is the exact ability we want to give to our AI.
This is SEAL, Self-Adapting Language Models. At its core, it's a framework that allows the AI to generate its own better study notes. We're talking high-quality synthetic data, to then fine-tune and literally update its own neural weights. It's not just learning, it's learning to teach itself. So, the big question is, how does an AI actually teach itself? This is where the engineering gets super innovative. The whole process involves this really clever two-loop system that's basically a form of meta-learning. The model is learning how to learn.
First, you have to understand this core concept they call a self-edit. This is amazing. It's the AI generating instructions in plain English on how to upgrade its own brain. This could be a list of key facts it pulled from a document, or it could be a whole set of commands to configure a training process. It is literally the AI's own plan for self-improvement.
Okay, so this whole process works with two nested loops. In the inner loop, the AI generates one of these self-edits, its study notes, and it uses that to temporarily fine-tune itself. Then, in the outer loop, the system evaluates the new, updated model. Did it get better? If performance improved, a reinforcement learning agent rewards the strategy that generated those helpful notes. So over time, the AI doesn't just learn new facts, it learns how to create the most effective study material for its own unique learning process.
And the flexibility of this self-edit is what makes it so powerful. For simple tasks like incorporating new knowledge, the self-edit might just be a list of key facts from a text. But for a really complex reasoning task, it can generate an entire configuration, choosing data augmentation tools, setting its own learning rate. In essence, the AI is learning to be its own machine learning engineer, which is just wild.
So, the theory is really cool, but the crucial question is always, does it actually work? Well, let's get to the results, because they are pretty staggering.
Just look at this. When trying to learn new information from a passage, the base model gets around 33% accuracy. If you just train it on the raw passage, it barely moves the needle. But with SEAL, where the model generates its own study notes first, the accuracy jumps all the way to 47%. That is a massive improvement. It proves that how you learn matters just as much as what you're learning from.
And here it is. This is the kicker. Get this. A smaller model Using SEAL learned to generate better training data for itself than a much larger, more powerful model like GPT-4 could generate for it. I mean, come on, that's a classic David and Goliath story right there. A smaller model that knows how to study can actually outperform a bigger, more powerful model that's just being spoon-fed raw information. The results on abstract reasoning are even more dramatic, if you can believe it. On a really difficult few-shot learning benchmark, standard methods just completely fail. 0%. Letting the model generate a self-edit without that outer reinforcement learning loop gets it to 20%. But with the full SEAL framework, it learns the optimal strategy and hits a 72.5% success rate. It's learning to configure its entire training pipeline on the fly. It's incredible.
So, let's zoom out. What does all of this mean? Where is this all taking us? Because this is way more than just an academic exercise. This is pointing toward a future of truly living, evolving AI systems.
Now, for any business leaders or AI strategists watching, this is absolutely critical. We are all rapidly approaching what they call the data wall, the point where we literally run out of high-quality human text to train bigger and bigger models. Future progress is going to depend on a model's ability to generate its own high-utility training data. This is how we scale intelligence past that wall.
And the path forward from here is just unbelievably exciting. We're talking about creating truly autonomous agents that actually learn and adapt from experience. An AI that can build its own curriculum, maybe breaking down quantum physics into simpler concepts to teach itself. You can even imagine a future where models teach other models, creating this whole society of continuous learners. And yeah, big challenges like catastrophic forgetting still exist, but this framework gives us a real path to finally solving it.
So, I'll just leave you with this. For years, the whole goal has been to teach an AI to provide the right answer. But now, we're on the verge of something way more profound. We are teaching it how to learn, how to adapt, and maybe most importantly, how to change its own mind. And that, well, that changes everything.